sp3d2 hybridization. For example, SF6, write all the electronic configuration for all atoms in the compound, and then draw the orbital diagram for valence electron of the central atom. We start with ground state, 3s2, 3p4, empty 3d orbital because S is in period 3, so it has empty 3d orbital. And promotion of electron, look at how many sigma bond or how many single bond does this S have. This S has 6 single bond or 6 sigma bond, so this S requires 6 unpaired electron. In the ground state, it only has 2 unpaired electron, so you have to make this pair to become unpaired, this pair to become unpaired, making 6 unpaired electron in promotion of electron. Type of hybridization makes all the pure orbital, and the electron involved in s orbital, 3p orbital, 2d orbital, 1 s orbital and 3p orbitals and 2d orbital. So that's why the name or the type of hybridization is sp3d2 orbital, because it involves 1 s orbital, involves 3p orbital, involves 2d orbital, leaving 3 empty 3d orbital. You have to draw this empty 3d orbital as well in drawing the type of hybridization. Next step, we know that sp3d2, how many sp3d2? 1, 2, 3, 4, 5, 6. 6 sp3d2 orbitals in total. Energy level diagram, write the ground state, orbital diagram of the ground state, and then when you mix the pure orbital, make it unpaired first, and then mix all the pure orbitals to become sp3d2 orbital, and the energy level of sp3d2 is slightly above 3p. Not exactly in between, it's just slightly above 3p orbital, and it's above 3s. That's the energy level of sp3d2, and empty 3d orbital is in the same level of empty 3d orbital in ground state of electron. 1s orbital mixed with 3p orbital mixed with 2d orbitals, making 6 equivalent sp3d2 orbital. 1, 2, 3, 4, 5, 6. You have 6 sp3d2 orbitals in total. And to draw the hybrid orbital, you have to look at the molecular shape. So this S has 6 electron group because it has 6 bond, 6 electron group arrangement octahedral. It has no lone pair at all, so the molecular shape is octahedral. So you have to draw the hybrid orbital in octahedral shape. Start with 4 plane and 1 above, 1 below. That is octahedral. And between all the plane, this 1, 2, 3, 4, between these 4 plane, 90 degree between them, and above the plane, above the central atom to the plane, 90 degree, and this below central atom to the plane is also 90 degree. So each SF sigma bond formed by overlap 1 sp3d2 hybrid. You overlap this one of sp3d2 hybrid with one of the 2p. For fluorine, you have to draw 2p orbital because in writing the orbital diagram for fluorine, the unpaired electron of fluorine is in the 2p orbital. So you have to search for unpaired electron for overlap with this hybrid orbital. That's why you have to draw 2p orbital, because the unpaired electron of fluorine is in 2p orbital. If you draw the orbital diagram, you can see the unpaired electron is in 2p orbital. So this is the final drawing of SF6 hybrid. Next example, XeF4. Same step. First, you have to write down the electronic configuration for Xe and F, and then draw orbital diagram for central atom Xe, and you can find the molecular shape. Finally, the molecular shape is square planar, 4 sigma bond, So you will have sp3d2 orbital, this 1 and 2 sp3d2 orbital has lone pair. And for the f orbital, 2p orbital, this f has unpaired electron in 2p orbital. That's why you have to draw 2p orbital to overlap with all 4 sp3d2 because it has 4 sigma bond. This is the final drawing of XeF4 hybrid orbital. Remember, you only do the hybridization for central atom. Electron group arrangement, octahedral because it has 6 electron groups. Molecular shape, square planar because 6 electron group has 2 lone pair. So square planar.